Again in this, we start by getting the gradient function. That's the first thing, the gradient function. So our gradient function dy dx, we differentiate this. So we have 2 times the coefficient of x, which is 1, we have 2, then x the power minus 1. Then when we differentiate this constant, we have minus 0 because the derivative of a constant is 0. So we are going to have therefore this as 2x, 2 minus 1 is 1, and therefore our derivative is 2x. Then we need to get now, we get the gradient, at the point which we are given as 2, 3. So we have the coordinate for x, that's y, x, y. So we have therefore our dy dx, which is now the gradient, will be equal to 2 multiplied by the value of x, which is 2, and therefore our gradient is 4. That is now the gradient of the tangent. That's the gradient of the tangent. So the gradient of the tangent in our curve, if this is our point and we have the tangent, the gradient here is equal to 4. And we want to find the equation of the normal. So if we have now our normal here, this way, we have the point here, which is 2, 3. We can take another imaginary point here, x, y, and we also require the gradient of the normal. And because they are perpendicular lines, that is the tangent and the normal, therefore the product of the gradient is -1. So we have m multiplied by m1 should be -1. Our m is 4, our m1 is in question, is equal to -1, so we divide by 4 by 4. So the gradient of the normal is -1/4. That is the gradient of the normal. Now we can use, we have the gradient, we have the point and the imaginary point. Now we use it to find the equation of this normal. So we simply come and note it. We have the following. We have the gradient, which is -1/4. We have the point 2, 3, and the imaginary point x, y. We know very well gradient is given by change in y all over change in x, and therefore our gradient is -1/4. Change in y, we have y minus 3 divided by x minus 2. Then we cross multiply. So we have 4 times y minus 3 is equal to -1. We multiply by x minus 2. So we open the brackets. So we have 4 times y, 4y minus 3 times 4, 12 is equal to -1 times x, which is -x. -2 times -1 is +2. So 4y is equal to -x plus 2. We take 12 to the other side, it becomes plus 12. So we have 4y is equal to -x plus 14. So we can write it in the form, we can leave it at this, it is very correct, or we can move ahead and write it in the form y is equal to mx plus c. So we'll have 4y is equal to -x plus 14. We divide by the coefficient of y, which is 4, we divide by 4. So we end up getting y is equal to -1 over 4x, then plus, we can divide this by 2 by 2, 7 over 2, or which is 3.5. So we have 7 over 2. And this is now the equation of the normal. And we can see clearly from this, our gradient is -1/4, the gradient of the normal. So this will give us the equation of the normal. So we need first, we get the gradient of the tangent. Then we can use m1 times m2 should be equal to -1 for perpendicular lines. we get the gradient of the normal, then we use the gradient and the points to get the equation. Lastly, the last example in equations of normals to a curve, we have the following. Determine number 3, determine the point on the curve. Determine the point on the curve. We have been given the curve y is equal to a half x squared plus 4, at which we determine the point at which the gradient is 8. That's the first thing. Then hence find the equation. Find the equation of the normal. Find the equation of the normal to the curve. At this point. So that is the question that we have been given. Again, is also a very simple question. We are told to determine the point on the curve y is equal to a half x squared plus 4, at which the gradient is 8. That should be the first thing. Then we are going to find the equation of the normal to the curve at that point that we'll get. So we have the equation of the curve y is equal to a half x squared plus 4. The point where the gradient is 8, and therefore we need the gradient function so that we can equate to 8. So the gradient function dy all over dx, this is our gradient, is equal to 2 times a half, which is the coefficient of x. We have, when we multiply by 2, we'll have 1. So we have 1x. Then we have 2 minus 1. Then the gradient function of a constant is 0. So we have this one as 1, that is x raised to power 1. 2 minus 1 is 1. So our x is the gradient function. And therefore, because we have been given the gradient, it's a very interesting question because we have been given now the gradient. So we know very well the gradient, which is dy dx, is equal to 8. And we have seen the gradient function dy dx is equal to x. And therefore it means we equate x to 8. And therefore our x is equal to 8. So that is the first point, because we want to get the coordinate now. Now we come and get the value of y when x is equal to 8, so that we can get that coordinate. So we have the curve y is equal to a half x squared plus 4. So we have a half. Our x is 8. So we have 8 squared plus 4. So we have a half. 8 squared is 8 times 8, which is 64. We multiply by 64. Then we add 4. So by 2 we have 32. 32 plus 4 we have 36. So the point, the y will have 36, and therefore our coordinate will be x8, y36. Then we are told, therefore, hence find the equation of the normal to the curve at this point. And therefore in that, again, we have the gradient, and the gradient is the gradient of the curve at that point, meaning that it is the gradient of the tangent. So if we have our curve this way, and this is the point, therefore it means that the gradient of this curve, which is the gradient of the tangent, so if the point is here and we have the tangent here, it is simply, if we have the curve and we have a point here and we have this as our tangent, it means that the gradient m is what we have been given as 8. And we want now to get the gradient of the normal. We have the gradient. We want first to get the gradient of the normal. And we have already gotten the point. The point here is 836. 836. So we get first the gradient of the normal so that we can be able to find the equation of the normal to the curve at the point 836. So we know for perpendicular lines M1, when we multiply by the gradient of the tangent, which is 8, should give us -1. So we can divide this by 8 by 8. So the gradient of the normal is -1/8. So we have the gradient M, which is -1/8. We have the point 836, and we have an imaginary point x, y. We have x, y. So we come and say gradient is given by change in y all over change in x. Our gradient is -1/8. Change in y, we have y minus 36. Change in x, we have x minus 8. So we cross multiply this. We are going to have 8 multiplied by y minus 36 is equal to -1 multiplied by x minus 8. So we are going to open the brackets. We have here 8y. Then we have 36. We multiply by 8. That is 288. We have minus 288 is equal to -x. Then negative and negative, +8. So we have 8y therefore is equal to -x plus 8. When we take 288 to the other side, we'll have plus 288. And therefore, it simply means that our 8y is equal to -x plus 288 plus 8, that is 296. So we can leave it at that, or we can write it whereby the coefficient of y is 1, whereby we just come and say 8y is equal to -x plus 296. We divide by 8 by 8 by 8. So we get that y is equal to -1/8x, then plus 296 divided by 8, that is equal to 37. And this is now the equation of the normal. This gives us the equation of the normal. We can see clearly that the gradient is -1/8, which is the same here, the gradient of the normal. So our equation, y is equal to -1/8x plus 37. And that's how we find the equation of the normals to a curve.